Hey everyone, and welcome back to DevOps Corner. Today, we are diving deep into a topic that is, completely reshaped modern software, microservices. If you're looking to really level up your system design skills, you have come to the right place. But hey, before we jump in, do me a favor and hit that subscribe button, and like this explainer. It really helps us create more content just like this for you.
All right, let's get into it. Our goal here isn't just to give you some textbook definition of microservices. No, we're going way deeper. We're going to unpack the what, the why, and most importantly, the how. We'll even get into the architectural patterns and the cultural shifts you absolutely need to build systems that are not just scalable, but also super resilient.
So here's our game plan. We've structured this masterclass into 6 key parts. We'll kick things off with the world of the monolith, then we'll see exactly when and why they start to break. From there, we'll dive into the microservices paradigm shift. We'll look at some real-world migration patterns. Think big names like Netflix and Uber. Then we'll get into the really cool stuff, the advanced architectural patterns. And finally, we'll tie it all together with the DevOps culture that makes it all possible.
Okay, so to really get why microservices are such a big deal, we have to go back to the beginning. We have to start where pretty much every single application starts, in the world of the monolith. You know, it's the traditional way of doing things, and for a very good reason. It's all about a simple, powerful start.
So what is a monolith, really? Well, think of it like this. It's one giant application where everything, the UI, the business logic, how you access data, it all lives together in one single code base. It's one repository, it gets compiled into one single executable file. Everything is just one big unit. This means all the different parts are super tightly coupled, all operating as just one piece of code. And there's a reason people start this way. For new projects, monoliths have some huge advantages. First off, development is just easier. All your code is in one spot. Deploying it is also way simpler. You've only got one application, one CI/CD pipeline to worry about. And when things go wrong, well, debugging is pretty straightforward because you're only tracing errors through one single system. All of this adds up to a much faster time to market, which, if you're a startup trying to get an MVP out the door, is absolutely everything.
But, and there's always a but, right? Here's where the problem starts. What happens when that awesome startup application actually succeeds and starts to grow? What happens when you need to scale? This is where that simple, beautiful monolith starts to show its cracks. This is the crisis of scale.
So the very first thing you'll notice is that your release cycles get slow, painfully slow. Think about it. In a huge monolith, even a tiny change, like a one-line bug fix in some minor feature, means you have to retest and redeploy the entire massive application. And as that code base gets bigger and bigger, this whole process becomes incredibly slow, not to mention risky. It just kills your ability to innovate and move fast. Okay, next up, scaling is a total nightmare. Let's say one tiny part of your app, like the shopping cart, gets slammed with traffic during a big sale. With a monolith, you can't just give the shopping cart more power. Nope, you have to scale the entire application. That means you're spinning up more instances of this whole massive beast. It's super expensive and just wildly inefficient.
And this brings us to one of its biggest weaknesses. Everything is tightly coupled. This means a bug in some small, non-critical feature can literally bring down the whole system. It becomes a massive single point of failure. Plus, it makes it incredibly hard to try out new technologies. Good luck trying to add a cool new Python machine learning service to your giant old-school Java application. It's a mess.
So this leads us to the million-dollar question, right? If monoliths are so great for getting started, why do you see all these huge companies, Netflix, Amazon, you name it, spend years and millions of dollars to get away from them? Well, the answer is all about solving those exact problems we just talked about: scale, speed, and resilience.
And the solution? Well, it's a total paradigm shift. We're not just talking about writing code a little differently. We're talking about completely rethinking how you structure your application. And that, my friends, is the microservices approach.
All right, let's put these two head-to-head so you can really see the difference. So, on one hand, you have the monolith, one single large unit. On the other, you have microservices, a collection of small, independent services usually built around specific business functions. Deployment? With a monolith, it's all or nothing. With microservices, you can deploy each service on its own. This is huge for scalability. You can scale just the service that needs it, not the whole application. Technology-wise, a monolith locks you into one stack. Microservices let each team pick the best tool for their specific job. And maybe the most important part, fault isolation. If your recommendation service goes down, who cares? People can still search for movies and stream them. The rest of the app keeps working.
Okay, so this all sounds great in theory, but what does it actually look like in the real world? Let's dive into the stories of how two absolute tech giants made this shift and look at the key patterns that came out of their journeys.
The Netflix story is probably the most famous one out there. And for them, this wasn't some theoretical exercise. It was a direct response to a massive business failure. Back in 2008, a single database corruption completely halted their DVD shipping for 3 whole days. That single point of failure was the wake-up call. It kicked off a massive 7-year migration over to a cloud-based microservices architecture on AWS. And that's how they built the incredibly resilient platform we all use today.
And a huge part of their strategy, something really revolutionary at the time, was something they called the Simian Army. You've probably heard of its most famous member, the Chaos Monkey. This is a tool that literally goes around and randomly shuts down servers in their production environment. The whole point was to force their engineers to build services that were resilient by default. It was a complete shift in mindset, from trying to avoid failure to actually embracing it and building for it.
So as companies like Netflix and Uber made this massive transition, some really essential patterns started to emerge. First, database per service. This is crucial. Each microservice has to own its own database. This is how you ensure they are truly loosely coupled. Then you have the API gateway, which acts as a single front door for all incoming requests, handling things like authentication and then routing the request to the right internal service. You also need service discovery, basically a phone book that lets services find and talk to each other even as they're constantly changing. And to deal with the sheer complexity of having thousands of services, Uber came up with what they call domain-oriented microservice architecture, or DOMA. This is all about grouping services into logical business domains like payments or maps to make it all manageable.
Okay, but let's be real. Moving from a monolith to microservices isn't a free lunch. It introduces a whole new set of challenges. You're now dealing with a distributed system, and that's a different beast entirely. So the big question becomes, how do you manage all this new complexity? Things like communication between services, keeping data consistent, and handling failures. Well, for that, you need some more advanced architectural patterns.
When it comes to services talking to each other, there are really 2 main styles. First, there's synchronous communication. This is like a classic REST API call, or something more high performance like gRPC from Google. The client sends a request and then just waits for a response. This is perfect for when you need an answer right now, like a real-time query. Then you have asynchronous communication. This usually involves a message broker, like this super powerful event streaming platform Kafka. Here, a service just fires off a message and immediately moves on. It doesn't wait for a reply. This is awesome because it decouples your services and dramatically improves fault tolerance. It's great for things like processing an order or sending a notification where you don't need an immediate response.
All right, now this next one is super important, the saga pattern. See, in a monolith, if you need to update a few different database tables, you can just wrap it all in a single database transaction. Easy. But with a database per service model, that's impossible. Each service has its own database. So a saga is how you manage a transaction that spans multiple services. It's basically a sequence of local transactions. Let's walk through an example. Step 1. The order service creates an order and publishes an order created event. The payment service is listening for that. It processes the payment and then publishes a payment succeeded event. Then the inventory service hears that and updates the stock. See the chain? But what if something goes wrong? What if the payment fails because the credit card is expired? This is where the magic happens. The saga triggers what are called compensating transactions. The payment service would publish a payment failed event. The original order service hears that and it runs its own compensating action. Maybe it changes the order status from pending back to canceled. It effectively undoes the first step. This is how you maintain data consistency across all these different services without a single giant transaction.
Okay, let's talk about building resilience, because in a distributed system, things will fail. The circuit breaker pattern is a brilliant way to stop one failing service from bringing down your entire system in a domino effect. It works exactly like the circuit breaker in your house. Normally, the circuit is closed, and requests are flowing through just fine. But if a bunch of requests start failing, it trips the breaker. The circuit moves to an open state. Now, instead of trying to call the failing service, it just fails the requests immediately. This protects the system from being overwhelmed. Then, after a little while, it goes into a half-open state. It'll let a few test requests through to see if the downstream service is recovered. If those succeed, great. The circuit closes, and everything goes back to normal.
All right, so we've talked a lot about architecture and patterns,
But there is one more piece to this puzzle, and honestly, it might be the most important one of all. You see, microservices aren't just a technical decision. They are a cultural one. If you want to actually succeed with them, you absolutely have to have a mature DevOps culture in place.
Just look at this number. This is the reality of what it means to operate at enterprise scale. Companies like Amazon and Netflix are deploying changes to production literally thousands of times a day. Think about that. It's impossible to do that without an incredibly deep culture of automation. This means you need sophisticated CI/CD pipelines for every single service, you need containerization with tools like Docker to package them up consistently, and you need a powerful orchestration platform like Kubernetes to manage it all in production. The bottom line is, your architecture and your operations have to be completely intertwined.
And that really brings us to the final, most important thought I want to leave you with. Look, the real goal of microservices isn't just to have some kind of technically perfect architecture. The real goal is to empower small, autonomous teams to build, test, and deploy their own software completely independently. It's all about business agility. So as you think about all these patterns and ideas, you have to ask yourself this one fundamental question. Is our architecture serving our teams, or are our teams serving our architecture?
And that's our deep dive into the world of microservices. I really hope this masterclass gave you a solid, practical understanding of this topic, all the way from the monolith to these advanced distributed patterns. Thank you so much for watching. If you found this useful, please do me a favor and hit that like button and share this with your colleagues. It really helps DevOps Corner grow. We'll see you in the next one.